Joining the CSI webinar around an introduction to AI. My name is Neil Hart. I'm Head of Enablement and Productivity at CSI, and in a couple of minutes I'll be handing over to Andy Feltham from Filament. A brief word about CSI. We're constantly looking at helping our clients find a perpetual edge over the challenges that we all face. And the key word there really is perpetual, because I think things are moving so fast that if you have a competitive edge today, it may not last much longer. What we see really are three major digital forces that are creating the need for this perpetual edge: digital acceleration, digital disruption, and digital threat. With digital acceleration, simply everything is getting faster. Doesn't mean it's getting better, but it's definitely getting faster. People are expecting websites to react immediately. They're expecting answers to emails immediately. It's all going much, much faster, fueled in a large part by technology. And part of what we want to explore today is seeing how we can use the technology to help us get an edge over that acceleration. In terms of digital disruption, we're seeing competitors coming out of all different areas now. It's no longer a case where your competitors are obvious. I don't suppose a while back that Nikon or Canon thought that Apple would be selling more cameras than they do, but that's the way that the digital revolution's working. And of course, with digital threat, we see almost every day in the newspaper some new cybersecurity threat coming along. And that's really where we've focused CSI to address these three challenges and helping our clients to do so as well. We address the threats around 5 different capabilities: architecture, the core compute part of what we do; data, we do, nobody wants an unsecure system; and cognitive and applications. What are we doing with the data that we're keeping secure inside the data center? But although we're a technology company, the real point are the outcomes. The technology is important and it's definitely critical, but it's not the end point. The outcomes are the end. We're not putting technology in for fun. We're putting it in there to meet a business need. And some of those outcomes, the way that we're working, is 4 fairly fundamental outcomes that people will be trying to drive towards, not necessarily just one at a time, but maybe even a combination. Growing, making your business bigger, more efficient, more productive, and capturing more revenue from clients. On the other hand, saving. Everything wants to be more efficient. The cost of compute is coming down radically, and that brings its own challenges as well. With innovation, thinking outside of the box, how do we take technology and make it work for us in a new way? Very much the focus of today's webinar. And protecting the whole lot, putting a cyber wrap around all the technology to make sure that data is safe, people are safe, and reputations are safe. The way that we drive that is through a process we call the 6 I's, and starting from identifying what problems need to be solved, imagining the possible solutions, implementing them or initiating that, integrating with existing processes, and of course improving. So in fact, although we say it starts at identify, it's really a cycle where everything gets improved, and around the whole lot is the immunized cycle, where we add the protection. And the reason I put that slide up is on the back of today's webinar, what we'd like to invite you to do is contact us and go through an identify and imagine workshop around cognitive solutions. So identify and imagine were the first 2 steps in that 6I process, with identify really being what are the challenges to be solved, and the imagine piece exploring those possible solutions, potentially even up to designing a full solution, a statement of work that can be implemented. So what we'd like to do for a half a day, start this exploration discovery exercise. It doesn't, with the identify section, of this process, you don't have to have a very definite problem in mind to start with. Anything's possible. We can just explore all the business challenges that you think might be able to be addressed by a cognitive solution or an artificial intelligence solution, and then explore that and see where we take it further. So please do contact us after the webinar. We can explore when we should be doing a workshop with you. So in terms of the cognitive solutions, I guess the question is, why now? Why are we having this webinar? Why is CSI investing in AI solutions or working with partners such as Filament? And it's really around the age of implementation. The fuel for AI is really data. And the more data you have, the better the machine learning model is going to be. If you have a little data sample, chances are the model's not going to be accurate. But of course, what that needs is an immense amount of compute power. And until recently, that was out of reach for most businesses. And what's changed fairly recently is that both of those have been addressed. There are masses of volumes of data being created now through digital business transactions, social media, Internet of Everything, sensors in cars, fridges, toasters, you name it. So there's no shortage of data. And what we've also got now is relatively affordable high-performance compute, GPU-based systems that you can acquire on a pay-as-you-go basis. You don't have to buy, almost unaffordably expensive high-performance compute. This is now available on a cloud basis. Use the GPU power where you need it, and then give it back again. And the reason that we're having this webinar today, and the reason that we especially have got Andy going to talk to us just now, is that we want to get AI out of the lab. Really, if you look at two creative processes of invention and innovation, the invention of AI has happened, depending on who you speak to, in the 1950s. AI was founded and starting to work, but very much in the lab, in academia. Now it's the time to start using the technology to innovate fearlessly, to solve real-world problems. And that really is the focus of what the webinar is about this morning. So I'd like to stop with the introduction and hand over to Andy, who's going to lead us through scaling our business and working smarter, not harder. Andy, over to you.
Thank you very much, Neil. Great introduction. So, assuming the controls work, they were working a minute ago. What I want to do is just talk you through very quickly a bit of an introduction to AI. This is not going to go into real detail about the algorithms or anything like that, so don't get worried that we're going to get too technical or anything like that. But what I want to do is show you the real potential of this technology, because it is really an exciting sort of changing point in the way businesses can work, the way they can reach new markets, new customers, or even just be more efficient at the things that they do themselves. And together we're here to help you on that journey. But a lot of people often sort of find getting confused about what it can do, what it can't do, how to get started, and so on. So hopefully today we'll cover a few of those things. First thing I want to do is just kind of it was working. Show you a little bit about Filament. As mentioned, we're a partner with CSI, and there's two things to show you here, really. We're about 35 people, so relatively small, but we cover all kinds of different industries. There's a great sort of dynamic with regards to machine learning that it's about the data that you have, not the industry you're in. So we can operate across photos and so on. But the other graphic on the left there is actually sort of a recognition that when it comes to delivering machine learning that works for a business, it's not just about academia. Likewise, it's not just about cutting edge technology and the latest and greatest thing to hit the shelves. You actually need a blend of things, including that kind of agency style delivery experience. Because at the end of the day, the machine learning component is just one piece of a much bigger puzzle within your application. It's often the brains behind it, but you still need a way of getting data to it, understanding the results from it, and being able to retrain it and so on. And we'll cover bits of that in a minute. But that kind of sweet spot in the middle is where we really see ourselves playing and allowing us to help you from end to end within that kind of application that you're trying to build. So as Neil mentioned, there is a long and dated history with regards to AI and machine learning. All the way back to the Turing test in 1943, we've been talking about the possibility of teaching machines rather than programming machines. And it's a fantastic kind of space to follow if you want to get into the research behind it all. You will notice there's this massive gap in between 1973 and 2008. And as mentioned there, it's kind of widely recognized and described as this AI winter, where fundamentally the compute power that was available to the people working in this domain didn't match the kind of requirements that they had for the algorithms they'd created and so on. So fundamentally, they were just stuck with the technology of their time and couldn't go any further. And it took a long time before there was a lot more research, and that those sort of things. Even when it came to 2011, when IBM submitted the Watson solution, that was a computer that filled a room, that had many terabytes of memory, that was loads of CPUs and GPUs and stuff like that. It was a big beast. Yet even in those last kind of 8 years since that has been released, we've seen that being improved and optimized and reduced in size to the point where now you can get these kind of things, via a cloud service or, installed on-prem and that kind of stuff. So some fantastic sort of challenges in that sort of space to overcome. What I find interesting is the last 3 bullets on there have all been sort of essentially revolved around the game. And obviously a lot of the research is driven by this desire to kind of prove a concept, that, a hypothesis, if you like. So in the case of Jeopardy and Watson, it was about being able to understand natural language in a way that same way that humans do. Turing test was less so of a game, but about deceiving, an individual into tricking them to thinking it was an actual machine responding versus a human responding. And then with things like AlphaGo, the complexity of this is phenomenal. When you look at Go, number of moves possible on the combination of a game of Go are more than there are grains of sand in the planet, and not by 1 or 2 sort of orders of magnitude, but by many orders of magnitude greater. So in this particular case, it's about demonstrating whether machines can actually be self-taught and optimize themselves to achieve a certain goal. So a fascinating problem there. And I talk a little bit about AI and machine learning interchangeably, partly because I think that's where most of society is at. We think about AI as this big umbrella over everything, when actually there's no sort of substance to AI. It's more about machine learning versus search and logistic reasoning sort of thing. Machine learning more so than others is where most of the applications are. And I sort of put this slide up mainly just to kind of get some terms across so that when you hear them out and about, you can become really familiar with them. Obviously, within the subset of machine learning, we've got supervised, unsupervised, and reinforcement learning. So to briefly cover those, supervised learning is very much like you would teach a child. You're giving them examples by which they can learn and derive new information from. You're saying that's an apple, that's an orange, that's a banana, etc. And then next time, with enough kind of examples, next time they see those kind of objects again, they'll be able to classify those things and say, oh yeah, that's an apple. I remember seeing that before because it was round and so on. There are downsides to this. Obviously, if you rely on teaching a child that an apple is always green, then when a red apple comes along, it's not always going to be very accurate. But those are problems that are easy to kind of get around. Unsupervised is about looking at the data in more of a structured format, being able to spot patterns within that format when looking at a set of dimensions of that data, set of features within that data that's way more than we can comprehend. So not just about X and Y time series, perhaps over value. It's looking at age and location and time and history of interactions and all these other kind of factors to be able to spot patterns that allow you to then make predictions and recommendations. Recommendations in particular, someone similar has also liked this thing, so therefore they might be interested in it, or making predictions that say this is likely to be very similar to something that's happened before. Reinforcement learning is a very underused kind of area of machine learning at the moment, certainly within business, but this is more akin to the kind of self-driving cars and areas where you're trying to sort of say to a system, all I need you to worry about is to get from here to there, as in achieve a goal. And here's how you measure how close you are to the goal, but just work it out yourselves. And the interesting thing about that is it kind of breaks down perceptions about how things should be delivered. So in the case of a problem where you need to transport something from A to B, the obvious solution might be something that looks vaguely like a car. But the nice thing about reinforcement learning is those sort of boundaries are broken down to the point where it'll create something that's right for the job you've given it, not for the kind of understanding that we currently have about how to transport things and that kind of stuff. So there's lots of different possibilities, but one of the things that I find really interesting is that people tend to think about what the technology can do for you. Like, isn't it amazing that I can do all these kinds of things? And get kind of distracted by the shiny things, when actually it's better to sort of look at your business and say, right, what do I need my technology to deliver for me? Because that's the thing that's going to deliver the most value, but it's a very fundamental kind of shift in terms of the way you think about machine learning. To put that into reality, a lot of people kind of start off with, potentially complex projects when they don't understand the concepts and they don't understand the pitfalls that can be present if you deliver it wrong. And instead, what you should be looking for is actually, what's the simple things that if I did in an automated way would give me a lot of time to concentrate on things that really matter? Or, how can I just change a small part of my business, something that I do regularly, because that'll make a significant impact to what I do. To put that into more perspective, what technology can do is absolutely phenomenal. Obviously, you've seen these photos from the first few slides, but the reason the rest of them are grey is because all of those photos on the right-hand side that are grey are people that do not exist. Indeed, if you go to thispersondoesnotexist.com, you'll be able to generate an image every time you refresh the browser of a person that does not exist. And these photos are, something that you would print on and put on your wall and no one would notice the difference, but they are entirely generated. And likewise, the photo on the left is something from NVIDIA where you can just kind of draw rough outlines of land and sea and trees and stuff like that, and it'll generate a photorealistic kind of picture as a result of your random scribbling sort of thing. So really, really complex and very impressive demonstrations of the technology, but actually I'd sort of question where the value is right now for these kinds of things. You don't need things like that. You need more simple kind of basic applications. And so, what does it actually mean? Fundamentally, machine learning is about making better decisions. It's about automating the bits that don't add value to the business that we do, so that we as individuals can concentrate on the bits that do add value. Recognizing that machines are better at some tasks than us, but that we are better at sort of compassion and understanding and logic, and being able to put a then we're not going to allow our business to grow. So, in terms of what it actually means, we want to use this technology to make decisions, to make predictions, to look at potential outcomes and automate simple decisions and that kind of stuff. Now, I find this kind of session from Kasparov very interesting, and I can relate to this a lot. But this is a man that was actually beaten by a machine a long time ago. He was the pinnacle of chess at the time. He was unbeatable. and yet along came a machine that was able to take his world from under his feet and do something that no one else was able to do. And you could imagine that but he's very quickly come to realize what I think we all need to realize, is that actually this technology is not there to replace what we do. What it's there to do is to actually enable us to do something that is going to add more significant value. It's that technology that we need to push us as a society on. If we're not able to sort of do the higher value things, then we won't be improving as a society. And as he points out, machines are very good at calculations and instructions and being objective and stuff like that, but we can actually be the ones that drive that purpose, that understanding, that passion through, and to dream about the sort of environment that we want to live in the future, sort of thing. And if we're not doing that, we're standing still. And if you as a business are standing still, then your competitors will be flying past you, because they're looking at ways at optimizing. They're looking at being driven on by this technology, not seeing it as a threat. If you haven't watched it, I strongly suggest you go and watch his video, because it's a very compelling argument for using technology in a positive light rather than a sort of a very negative, it's going to take over everything we do kind of light. So in terms of building these applications, I think there's lots of different views around how applications can be useful. I like this as a sort of an overview of what can be possible, or a way of thinking about things. It's touching upon that sort of point that not everything has to be complicated. There is a spectrum of outcomes of the application that you can build. Everything from simply tell me what is going on right now, all the way through to taking preventative action, intervening, in the case of a self-driving car, perhaps putting on the brakes and that kind of stuff. And with this spectrum, there is a sort of inherent cost and complexity kind of impact. But even those to the left of the middle don't have to be expensive, yet can actually drive quite a lot of value and a lot of savings in your business. So likewise, what happening now, what do I need to do? I make some recommendations, some predictions. Automation starts to fall into the world of sort of robotic process automation, or RPA, actually taking some of that logic and actually wrapping it into an end-to-end process, and so on and so on. But for me, it's a good kind of way of being able to think about your application and scope it down to actually what you need to do in that kind of context, that kind of use case. Moving a step on, it's actually interesting that when I talk specifically about machine learning and those three kind of scenarios, supervised, unsupervised, reinforcement learning, there are a lot of just use cases that fall into those buckets that, again, are not specific to industry or anything like that. And I'll leave this slide on for a little bit, because I'm sure it's not hard for pretty much any business to find some of those areas that are applicable to them and that solve real problems in what you do. So customer segmentation, big area for retail, for example. Fraud detection is a great example in financial services, being able to spot patterns in data that might lead to suspicious activities, retention and forecast, and so on, and so on. And the beauty of all this kind of statement is that you'll find that there are fantastic examples about each of these kind of types of application in a way. And although they might be in different industries, they are using data that is also in yours. And so it's possible to kind of learn from those scenarios, understand what worked well, understand what didn't, and transport that over to your industry and your use case, sort of thing, and build applications that actually deliver value, sort of thing. Obviously, this is not giving an indication of data, but for example, if you were just to look at classification, that sort of bubble at the top on the supervised learning, classification is a general task of just being able to spot things within data. So whether that's spotting sort of patterns in images or patterns in text, the process is still very much the same. And we can use that to kind of create annotations that might inform business decisions, or that might route information in different kinds of ways, route invoices to one department and route complaints to another, at a very simple level like that. And those in themselves are enough to kind of make significant time savings and free up people to do the work that they really should be doing. So, and I can even sort of summarize this in sort of more simplistic fashion. These are sort of obviously lots of different buckets, but for me, most people are falling into potentially one of four buckets of machine learning that they're trying to implement to start with. There's the sort of more familiar, perhaps, conversational interfaces that most people refer to as chatbots, but I think has a lot more potential than that. There's natural language processing of all kinds of information, whether that's social media, whether that's publications and reports, whether that's web pages or news articles. Doesn't matter. The processing is all the same in terms of pulling out entities and things from that text. You then got general categories of computer vision, looking at the pixels, spotting patterns, recognizing objects, all those kind of good things. But again, it doesn't matter if that's an image taken from a chest X-ray or whether that's an image on a factory floor trying to spot defects before products go out the door, kind of thing. It's the same process. And then you've got sort of time series-based data, which is obviously very sensitive and requires quite effective processing, but it's about the here and now. What's happening? What can I prevent happening? Can I try and identify things, faults or trends or whatever it might be, and get ahead of the game a little bit and use machine learning to kind of try and give you insight that you wouldn't have necessarily been able to comprehend beforehand. And what I want to do is just kind of give you a few examples of each of these and just really demonstrate why they are so powerful as a category of applications. The first of which is around customer service and conversation interfaces. And this was a project we did for HSBC, and this touches upon my kind of earlier point that applications with machine learning don't have to be glamorous to demonstrate real value. In this particular case, they were delivering a chatbot which was going to answer some very simple FAQ style questions, but the business had recognized that there was a high volume of those questions. And so if they could optimize them, then they can spend more time on the phone, on the chat with people that were maybe looking to leave the bank or that had complaints that they would be able to solve, or simply just to spend more time with that individual, not feel like it was rushed. And so I think these were figures from the first 3 months where 14% of those conversations were able to be completed without human interaction, and saved 12 minutes per chat, cut the handling time by 50%. And those kind of metrics and metrics that could apply to any industry with volumes of messages, and you'd be able to get kind of similar savings. Indeed, 2.5 times more productive than an agent, or 14 times reduction in the cost per interaction with a customer. I don't know any industry or any business where that wouldn't be seen as being a very positive kind of interaction. Now, this is just one such example where it's focused mainly on customer service, but actually as a platform, natural language processing and that kind of conversational style could apply to so many different use cases. And I'm on a mission personally to stop referring to things as chatbots and more like digital assistants, more like a sort of a conversational agent. Because if it is a conversation, then you can start to triage things into different up the proactive. You can automate things. You can build a much richer environment that actually calls external APIs to actually trigger events and so on to happen. And I want to break that perception that a chatbot is just about FAQs. It's actually just the next user interface that we'll all be using, because it's on devices that we carry around with us, every day of the week, 24/7, pretty much. So have a think about that in terms of how that might apply to your business. But I can guarantee there will be some way that we can get that to work for you. Going back to those 4 scenarios, then the other one is around natural language processing. And this again was something we've done for a private equity firm, where currently they had a very manual process to perform market research, find companies, the diamond in the rough, that was worth investing in, that was going to generate a significant return on that investment. And when you talk to the business, there's a very manual process which is very biased towards certain industries and certain places where information has previously been found and so on. And yet, from a business like that, the value is about being able to scale. And typically their approach to scale before was to hire new people and to scale kind of linearly. The alternative approach is to use machine learning and to scrape pretty much everything that is available there. So starting from the information that's freely available in Companies House, you've got your list of 3.5 million companies in the UK, and you can start to identify information within that set of records. The directors that are mentioned on the financial reports, we can start finding out about them through LinkedIn, through Twitter. What are they talking about? How are they talking about it in a positive light and a negative light? What the frequency is. Likewise, we can look at all the websites, URLs that are associated with all that information and start scraping them. What are they talking about? What are they kind of referring to? Again, in sort of what sense? How does it relate to other companies? And so on and so on. And so throughout all of this information that's out there, we can build this network of information, this metadata about a given company that can help us inform a decision about how likely they are to be profitable in the future and worthy of investment. And indeed, putting all of that information together in a unsupervised kind of model allowed us to make recommendations. And what this is doing for that PE firm is cutting down the amount of time it takes to research companies, but also increasing the accuracy of those companies that they spend time looking at. And indeed, I think in the first 3 months, they doubled the number of investments they were able to make, including investments in areas that they wouldn't normally have invested in. Employees for them that is able to work 24/7, 7 days a week, looking at all the information. And it's not just about that initial kind of result, because as part of that machine learning process, we factor into that sort of a learning process, so that actually if there's a recommendation that they don't feel is relevant, they can reject it, and that actually contributes to the data that helps that machine learn over time to get to the point where there's more and more recommendations that are more and more accurate. And so, phenomenal kind of amount of data, yet boiled down to a very simple decision. Do I recommend this company or do I not? And if I do recommend it, get feedback from that individual about whether it's a good recommendation or a bad recommendation. To put this into context, I think I like this kind of analogy. When we talk about a lot of data, everyone talks about the volume and the velocity that data is created in today's society. There's gigabytes and gigabytes and gigabytes of data created about any individual on any given day. But data is not necessarily what you need as a business, because data will tell you that someone has tweeted, or that to translate that through into knowledge that you can then act upon. So in this particular case, that step in the middle of taking data into information and actually put it into context gets you a little bit further down the road. But then actually that knowledge of being able to understand how that information relates to your context and your business, so that you can make an advantage is make a decision is a real competitive advantage sort of thing. So you get to the point where actually for example, not to recommend somebody a particular product because of A, B, and C, or specifically to recommend someone a product because they've just done all these kind of things that are mentioned in that data. And Microsoft did various studies on this kind of front, and it's a common scenario. People struggle to find information despite the fact that we've got information anywhere. And actually, it's not the information that they need, it's the knowledge, the confidence in that knowledge to actually be able to make decisions in an informed and kind of efficient sort of way. Again, the links are at the bottom of the pages if you fancy a read. Again, it's very enlightening. Going back to those few use cases again, just to touch upon a computer vision use case. Some of these are very obscure, but actually save a lot of time and a lot of money for businesses. This is a project we did with a scratch card operator, where they needed to be able to ensure that the scratch cards were full and that they were showing the right ones that were on promotion at the time, and so on and so on. So they asked all of the shopkeepers to send in photos of their displays. Now, I'm sure you can imagine the amount of time it takes to process those photos and to actually talk to the shop and say, yep, those are all fine, or indeed, no, that one's empty, why is it empty, and so on and so on. So we used the computer vision sort of scenario to classify the 40 different types of scratch cards, and then to kind of identify, to identify the actual scratch cards themselves, and then to classify them into one of 40 different categories. This was an example of one of the photos in the bottom left-hand corner, and you can see that this is not a simple problem. All of the cards are, similar kind of colours and styles. They're all the same shape, but some of the photographs are taken square on, some of them are taken at a little bit of an angle, and so on. And so there's a kind of potentially complicated challenge there to be able to identify those things correctly. But it's a kind of a known problem, and given enough time, it's quite easy to be able to get to the 95% of accuracy statement with regards to detecting the objects, and then 98% accurate in terms of actually classifying that as one scratch card or another. And for a business, what I can do is just completely automate that process of checking every single store in the country when photos are uploaded of that status at that given moment in time. So that means people might send photos more frequently, which means you get a more accurate, up-to-date statement, but it also means you can free up people to actually talk to that store and ask them what else can help them drive more revenue, what else can help them to get to their clients better, and so on. Fortunately, this is not just something that needs to be done on the cloud. There's some fantastic developments in what I describe as edge computing with GPUs in. So both Intel and Google have released these kind of little USB devices that plug into things like Raspberry Pis or small laptops to actually allow you to do image processing at the edge of the network. So it doesn't matter whether it's a traffic sensor or something else like that, you can send the result of the classification back, not the whole image that is potentially taking up a lot of bandwidth and so on. So really fascinating to see how that will develop over time, and I can see a lot more edge AI coming to fruition in the next kind of few years. Quickly moving on then, just to talk about the time series data. Again, this is about kind of making predictions. In this case, this was an energy company that was trying to spot the energy patterns in a 24-hour time window. So we looked at the kilowatt hours consumption over the previous 12 months of data, and we looked at other features such as weather and day of the week and events and things like that to be able to kind of spot those trends in order to make better predictions. Now, we were wrong 2.6% of the time, which is a fantastic kind of level of accuracy. And as you can see, it's not a big, complicated project. That was 4 weeks worth of effort to understand the data, understand how the features relate to each other, and build a model based on that. But what it enabled people to do was then predict based on that and take necessary action, whether to kind of use different sources of data, of energy, or buy an energy from slightly cheaper sources rather than at demand time when it was really needed, sort of thing. But the same kind of process can be applied to any types of predictions, whether that's fault detection on IoT type devices or machinery. It doesn't matter. It's about predicting events within time series data. And within all of these, I've been talking about the use case, but just as a final couple of slides, one of the things I wanted to just kind of convey to you is that while it's straightforward to build these models, there's often a lot more to it in terms of that application. We talked about the data a bit, but actually data is just one part of it, because it's not just the volume, it's how quickly it needs to be processed, how quickly before it goes out of date. All the different types of data that you might have, whether it's all natural language or natural language plus a bit of structured data, plus a bit of image. There's lots of complexities in terms of creating that. Building the model in itself is essentially can be a complicated task, because often you'll find that the data scientists that are good at building those models are not the subject matter experts in that area. So, in some cases, we're able to become subject matter experts. Understanding 40 different scratch cards is one thing, but you're not necessarily going to build a model if you don't understand, the cells on a cancerous X-ray or something like that. So the way to create that model is by blending together those subject matter experts with the people that are able to kind of build that model, so that you get, a true representation of what's in that subject matter's head into a model that you can then scale and build. Obviously, once you build it, you've then got to integrate it. And again, this is no simple task in some respects, because you want that integration to be scaled up and down depending on use. You want to be able to learn from how that model is used to be able to retrain it and accommodate scenarios that it might not necessarily have seen before. So it's not just about calling it, it's also about capturing how it's been called, what the result was, and being able to learn from that. And then, the reuse is the final point that I think lots of people don't necessarily appreciate. I think if you're reusing a bit of code, that's one thing. You clearly save a bit of time in terms of not having to write something again and again and again. But actually, when it comes to machine learning, what you're reusing is all the knowledge that you've used to train that machine learning model. And it's that bit that's really fundamental, that if you don't build your models in such a way that enables them to be reused, then each time you're creating something, you're having to teach it again and again and again. And instead, what you want to do is to continue to be improving and evolving that model so that it's able to understand more scenarios and able to kind of work in different sort of ways. So that the more you can facilitate reuse of existing models, then the better it is for your business. And by that, I mean sort of breaking them down into, a model to classify X could be used in your front of house campaign as well as your back of house kind of automated processes and so on. It's the same model, it's just used in a different sort of context. And then, in terms of, where to go, I think the interesting thing is that there's lots of ways in which you can start. You can dive in at the deep end, or you can take some of the code yourself and have a little play around with it. But the projects that we've worked on in the past that have been the most successful are the ones that actually evaluate the application first. So, machine learning is as much of an art as it is sort of a science, really, because while the theory, will always work and it will always allow you to kind of take data, train a model and produce a result, that result is not always going to be what you'd expect it to be. And so you might need to get additional data, you might need to go around that process a few times. And that evaluation step allows you to understand the dynamics of your data and the capabilities of what you can build first, before you've invested significant amounts of money in. On the slides before, I've talked about, kind of 3 to 4 weeks as a kind of appropriate evaluation stage. In this kind of time, what we're trying to do is really break down assumptions into really basic terms and say, let's build something that just proves the decision that I want to prove, and not necessarily think about those integrations or that reuse or whatever, but prove whether it's worth developing further iterations through with that application. Once you've then evaluated it, then you can start to implement it, actually scale it up to connect it up to things, to include different types of data and so on, before you look at then scaling it and making sure it works across lots of different geographies, etc. But you do need that kind of evaluation stage at the start to be really important and a key decision. I guess in all of the slides that I've talked about, the other thing to bear in mind is that at no point have I spoken really about the technology. We need to understand the context that this technology is used in, so that we can, have a grounding of what's possible and what's not possible. But actually, in all of these scenarios, it's starting with the problem first. What is it that you're trying to solve? What's the biggest blocker for you that enables or prevents you from scaling your business? Because that's what you need to look at. And it may be that you have the data that you need in order to build a model to solve that. But in most cases, it's actually a case of combining data you have with data you can get hold of. potentially internal data that you've built up over the years, combined with external data like weather predictions and so on, enabling you to make better decisions about when you can sell ice creams and where to sell ice creams, for example, something like that. If you contrast, you start from the other way around and you say, what data do I have? What can I do with it? You'll find you'll solve problems that you don't necessarily need to solve, and you'll be limited by the data that you've been collecting in the past. So think broader, think in terms of the problems that you've got, and look to existing use cases that have already been demonstrated, that have already been kind of evaluated as a starting point. I talked about chatbot, stuff in the past, but obviously, that's a proven scenario, for example. But you can start there, or you can take it on a step and use a chatbot, for example, as a means of classifying images, or getting text from information from people, and so on. And it's really compelling when you start looking at the problem that you really see the potential of that kind of technology to be able to scale. Ultimately, I talked about what machine learning is about, and to come back to that point, this is really about capturing what is unique in your business, because that's going to be the thing that differentiates you from your competitor. And if you can capture that in a way that allows you to scale it, then automatically you can reach new customers, you can expand into new regions, or you can simply do things more effectively, and keep that interaction with your business consistent, and so on. Again, it's one of these where it's a journey. You're not necessarily going to do one application and then move on. So, I'd encourage you to look at this as what application do I want to start with that is easy for me to get my hands around, and use that as a springboard to then look at other applications within other areas of your business. Because I guarantee you that if you spend enough time looking at it, you'll find 10 to 15 different scenarios and different applications where you could apply this technology to, and in doing so, optimize lots of different parts of that business sort of thing. And that's what we're here for. We're here to help kind of understand those use cases, understand how your business works, and where this technology would really be most beneficial. And if you get stuck coming up with ideas, then obviously we can have conversations with you and actually thrash out what the right approach is and where to start, sort of thing. Hopefully that sounds useful for you. So I realised I've kind of rattled through that a little bit, but just as a quick opportunity to ask any questions at the end, or have a quick conversation. As long as you've got one thing from this session, that it's a technology that it's here to stay. It's very realistic and plausible to build applications that are going to make a significant difference to your business. And fundamentally, that this is the point in time where technology is at that tipping point of becoming practical, and not just a sort of a hyped up term that everybody's heard about but no one's using. We're talking to people in all kinds of industries, about applications that you wouldn't even think of immediately, and all of them are delivering value for that business. So if you're not building it, then chances are your competitors are, sort of thing. But with that, I think I will pass back to Neil, and if there's any questions either now or afterwards, feel free to drop them into me, and we can get answers back to you.
That's brilliant, Ali. Thank you very much for spending the time, and thanks for everybody who's been on the webinar. If you do have any questions, please, if you want to ask them now, or certainly after the fact, contact CSI or Andy, and we'll get back to you. I think the last thing we want to just say is the next in the series on AI, a session with Chris Parsons from IBM, getting a little bit more detailed under the bonnet, I guess, into the architecture that is, how do you optimize architecture for AI projects. So that's Thursday, the 6th of June at 11 o'clock. I hope you can join us then as well. Thank you to Andy. Thank you to everyone who attended, everybody who organized today's session, and I wish you a good day. Thanks, everyone.
Thank you.